Welcome to your lesson. In this lesson, we'll talk about sine and cosine ratios and use them in problems. Let's take a look at this triangle. We have angle A, B, and C. And we're going to use angle A to label the triangles for us. So now with respect to angle A, this is the opposite side. This is the adjacent side. And this is the hypotenuse. Well, that never changes. It's always the longest side inside the right angle triangle. Again, let's go back and talk about the opposite sides. The opposite side always faces the angle. The hypotenuse is always the longest side, and the remaining side is always considered the adjacent side. So what are the sine and cosine ratios? The sine and cosine ratio states that sine of an angle A, in this case, it's the opposite side over its hypotenuse, while the cos of is equal to adjacent side over the hypotenuse side. And last but not least, we already covered the tan of an angle is the opposite side divided by the adjacent side. In a short form or shortcut, we call it SOHCAHTOA. The reason why we call it SOHCAHTOA is, look, we have sine, and that's opposite over adjacent, opposite over hypotenuse. We have cosine is adjacent over hypotenuse. We have tan, which is opposite of adjacent. So SOHCAHTOA is a short way to remember these trigonometric ratios. Now let's use sine and cos to answer some problems. In the given triangle DEF, identify the side opposite of angle D and the sides adjacent to D. So let's take a look at the angle D. It's situated right here. The opposite side, the side that's always being looked at, angle D. So for angle D, the opposite side is equal to 5 centimeters. While the adjacent side is situated right here. How do we know this? Because the longest side is the hypotenuse and it is opposite to the 90 degrees. So the adjacent side in this case for angle D is 12 centimeters. So for good measure we also will write hypotenuse for the 13 centimeter length DF. Now for B, it asks us to determine sine of D. Well, sine of D has, or sine, using SOHCAHTOA, sine is opposite of hypotenuse. Opposite of hypotenuse. That means the opposite side is 5, while the hypotenuse side is 13. Now the cos of D, is look again at SOHCAHTOA, is adjacent over hypotenuse. Adjacent over hypotenuse. And adjacent side is 12, and the hypotenuse is 13. So the cos of D is 12 over 13. Now always go back to the question and see if you answered the question correctly. Determine sine of D and cos of D to the nearest hundredths. But we haven't solved this question to the nearest hundredth. We left it in a fraction form. So let's change, and on your calculator, punch 5 divided by 13 and round off to nearest hundredths. Hundredths means 2 decimal places. 2 decimals. And the answer for this would be 0.38. For cos of d, it's 12 over 13. 12 divided by 13 on your calculator with 2 decimal points is 0.92. And here are your answers. Let's take a look at a different example. Determine the measures of angle G and angle H to the nearest tenth of a degree. Let's take a look at angle G and label the triangle with respect to angle G. Meaning, the 14 is the longest side. It faces, or it's opposite to the 90 degrees, so this is your hypotenuse side, which is H. The 6 is next to angle G, which is the adjacent side, A, and the missing side, which we do not know, is the opposite side. Also, it is good practice to write SOHCAHTOA to refresh our memory with the trigonometric ratios. Now, what else can we find? And what else can we use? You should ask yourself, can I use the sine to find the angle? Well, we would have to have the opposite side and a hypotenuse. We don't have that, so SOHCAHTOA is out of the question, or so is out of the question. How about for cos? Do we have the adjacent side? Yes, we do. Do we have the hypotenuse side? Yes, we do. So we can use it to solve for our angle. So let's write cos of G is equivalent to our adjacent side over hypotenuse side. And let's plug in the information that we do know. Cos of G is equivalent to our adjacent side, which is 6, over 14, which is our hypotenuse side. Now, when we're solving for the angle, we'll always take the inverse of the trig functions that we're using. So in this case, it's cos. We'll take inverse, or inverse cos of 6 divided by 14. And another way you could write is cos to the negative 1 power 6, 14. That's a special way to write inverse. On your calculator, you would punch it in as second cos. We then will get a specific value, an angle, and make sure that it's always in degree mode. Not in radians or gradients mode, but in degrees mode. And our angle turns out to be approximately 65 degrees. But since the questions ask you to provide the answer to the nearest tenth, you have to be a little bit more accurate. So the answer is actually 64.6 degrees for angle G. So we solved for angle G, but we're still looking for angle H. And angle H is a little bit easier to solve. I'm going to do it right here in this rectangle, or at least a figure that looks like a rectangle. It's a little bit easier because we're going to use the idea of the triangle and the angles that add up to 180 to solve for this missing H angle. So we know that the sum of the triangles is 180, and that one of the angles is 90 degrees. So we're going to subtract 90 from that. Then we're going to subtract the angle that we already know, which is 64.6 that we calculated, and the result of this would be angle G. And this angle G turns out to be 25.4 degrees. And that's your angle G. If you put it back into the equation, add 90 and 64.6 to it, they'll have to add up to 180. That's one of the definitions of a triangle. Let's take a look at the last example. A water bomber is flying at an altitude of 5,000 feet. The plane's radar shows that it is 8,000 feet from the target site. What is the angle of elevation of the plane measured from the target site to the nearest degree? Let's draw this triangle. So we know that the water bomber is 5,000 feet from altitude. That means it is 5,000 feet from the ground. And so this is the ground. And it is 8,000 feet away from its target, right here. So the question is asked, what is the angle of elevation? So where is this angle of elevation? The angle of elevation is from the target site to where the plane is. And I'm going to have it in green. And let's call it target, or T. So how do we find this angle? Let's label the triangle based on this reference angle. So again, T is looking at the opposite side. That means the 5,000 feet elevation is opposite. And the longest side is 8,000 feet because 90 degrees is looking at it. So that is the hypotenuse. So based on this information, opposite and hypotenuse, right, SOHCAHTOA, and decide which trig ratio you're going to use. We have opposite and hypotenuse, and the only one that has opposite hypotenuse is sine. So we're going to use sine to find this angle, this target angle, or this angle of elevation. So write sine of t is opposite over hypotenuse, O over h. Therefore, sine of t is opposite is 5,000 feet over hypotenuse, which is 8,000 feet. In order to find this angle, t, we have to take the inverse sine of sine with to the power of -1, 5,000 over 8,000. So again, remember you're in degrees mode. You have to press second sine, and your t, or your angle, to the nearest degree, make sure you're reading the questions very carefully, to the nearest degree, is going to be 39 degrees. And here's your answer. And I'm just going to box it. We don't have to box the answers. We just see it. So it appears, the answer seems more important, and it's more visible for us to see what the answer is. That's why we box it. So again, make sure that your calculator is set in degree mode. And you press second, in this case, sine, to find the inverse sine.